Hi guys, this is Zach, and this is my video on calculus. The first part is about how to find rates of change of a real life road in Seminole. And the second part is finding rates of change of the stock graph. There's two examples that have real life applications. Have fun, guys. Here I am by the Seminole Police Station on the underpass that goes to the other side of the highway, and there's a sloped road here. And this sloped road has a grade, meaning it's a percentage. That means that every 100 meters that this road would hypothetically go, there is 12 meters, because the grade is 12%, that the road will rise or go down as it's a slope. I can use this grade as a y-x value to use calculus to figure out rates of change on different sections of the road, like the vertical value of the drive.
Okay, so by using the grade that I just showed you in the video, and knowing that for the grade means that for every 100 units the road goes up or down 12 units, we can actually make a triangle and find the hypotenuse of that triangle by using Pythag. And by looking at Google Maps, we can make a similar triangle that uses the actual distance of the road found on Google Maps for the hypotenuse. And to calculate rates of change, we want to find the real distance of x and y and not the ones found through the grade. And to do that, we can use similar triangles, so we can get x over x of each triangle, and then the hypotenuse over hypotenuse of each triangle, and do the same thing with our y values, and that gives us 99.285 meters horizontally and 11.9 meters vertically. So now we know that x equals 99 meters and that y equals 11.9 meters, and we can use the speed limit to decipher that the rate of change on our triangle is going to be dh over dt, and that will be 30 kilometers per hour, but we will change that to 8.3 meters per second, and that we are looking for the rate of change of dx over dt and dy over dt. Now dx over dt is more meaningful, as that means that we are looking for your rate of change as you get to the top of the road, and when you eventually go to the stop sign, which means more than if we're going up or down the road. That doesn't really matter to us. And since we're looking for dx over dt and we don't know dy over dt, and we want to use Pythag, we are going to want to change y into terms of x. And to change y into terms of x, we'll use the same similar triangle, and we can use the grade triangle that I showed you before with the 12 and 100 values, and we just say that our x and y value can equal the y value of the grade and the x value of the grade, which makes y equal to 25x over 3. So now with this messy writing, if we plug the number value for y as x, and find the derivative of x squared plus y squared equals h squared, which should be pretty self-explanatory, as the 2's will go to the front and cancel out, and we'll just have to multiply by dx over dt, because we're looking for this with respect to time. Okay, and whew, this is messy. Wow. So now here you can see that I factored out dx over dt to give us dx over dt x plus 25 x plus 3 equals h plus dh over dt, and then we can divide x plus 25x over 3 from each side to isolate dx over dt, which gives us this, and I can plug all the numbers in that are used from this triangle over here, which give us a final answer of 3.24 kilometers per hour, which is the rate of change of the car when it reaches the top of the hill. Whew, holy shit. See that this is the antiderivative of the road here. This would just show us the area of the road, which doesn't really mean anything, but if I wanted to, I could plug in different x values of the road, and I could figure out things between, which I guess could be useful if you were digging a hole or something. You had to figure that out. You had to figure out how deep the hole was, maybe something to do with the electrical or plumbing underneath the road or sewage, but things like that. So you can find the total area underneath the road and total area at different sections of the road by plugging in different x values and subtracting them to find different areas. Yeah.
Now it's time for me to talk about Newton and Leibniz to meet the requirements for the project. Newton and Leibniz, they both graded calculus independently of each other. Newton's idea of calculus began in 1665 to 1666 and was based off his understanding of physics, which led him to creating a deeper understanding of things like rate and change, allowing him to further understand the physics of things like planets and gravitation, for example. And Leibniz, he more focused on mathematical concepts, developing formulas and his famous Leibniz notation, differential and integral calculus, and even the product rule. They both had like the same big picture, but they developed their ideas in different ways. And although Leibniz published his work first, it is thought that Newton had actually worked on his work first. So both are credited to the creation of calculus. So it's still difficult to choose one or the other. And it's important to just appreciate how they both advanced mathematics to what they are today. And I'm not reading off a script. Now, time for the stock market part.
Okay. After almost 2 hours of trying to figure out Desmos, I've done it. So here's Microsoft's stock graph, and I wanted to find the rate of change of the US dollar per month between some points between April and June. So on Desmos, I made a table, and 1 represented April, and 3 represented June. 1.5, 2, and 2.5 represent those increments of the months between these Y values. This is the money that is represented at these points in time. For example, April 1st being $382. We have 1 at $382, and it puts these points on the graph. Now, using Desmos' regression system, we can pick these different types of graphs that will try and fit towards this graph. But we can see that a quartic graph actually gives us that R equals 1, or R2 equals 1, meaning that it is perfectly fits on a quartic graph. So this is a graph that represents these points on the stock graph. Now, here I have the derivative of that graph, which I'm going to enable right now. And this derivative can show us the rates of change at those points in time. And we can see, by looking at this graph, we can see how the stock price is changing at what time of month, or what month of the year. So we can see this first point. In April, we can see that it is coming down steady, that it's not increasing or decreasing much at all. And as the months go on, this dot right here, representing May, we can see that it's trending, this green line is trending upwards, and that the rate of change of the stock graph peaks at around this point, which is about 3/4 of the way till June. And we can see that as this graph goes down, it means that the price of Microsoft stock is increasing at a lower rate, and that if we extrapolate this graph, we can predict that as time goes on, Microsoft's stock will continue to increase at a lower and lower rate. And it is still increasing because it's in the positive axis, but the stock would be decreasing if it went to the negatives. Now, something else with Desmos that we can use is by using the equation of our regression graph, we can actually define it here, and we can plug it into an integral, and it can just calculate our integrals for us. But we can just type which 2 points. 200 here is representing May, and 300 is representing June, and we can just plug it in between these 2 points. And by enabling this, I can show a visual representation of this integral. I'm just showing the y values between 0 and when this graph is between 200 and 300. And there, we can see the area of this graph, and this area can show us not much to do with the stock graph, but I find it's interesting how easy this is to do with Desmos. And you can just show, I guess I can show the overall difference in, it's a good visual representation of difference in price increase and decrease. For example, if we had this right here, we would see that it's a lot less area shaded in, meaning that this area included a lot more. But yeah, Desmos is pretty cool, guys.
It's like 10:30 now. Started this at 7, so it's pretty good. Oops, my hand was covering the mic. Okay, thanks for watching. Like and subscribe. Bye.